This conference will now be recorded. This conference will now be recorded.
Hi, welcome to a demonstration on remote peering connection. So what we're doing today is replicating the image or the diagram that we saw during the remote peering connection lesson. We're going to be creating a virtual cloud network in Sydney, region 1, and another one in Melbourne, region 2. And we are actually going to be using these settings, the same side of block for VCN1, the same side of block for VCN2. So let's go ahead and take a look. So here are the resources that we previously created during the other demos. We are going to be working out of these two regions, Sydney, and I already pre-created Virtual Cloud Network 1 in Sydney and Virtual Cloud Network 2 in Melbourne. And I even added the permission for Echo on the security list. I also created two virtual machines with SSH keys so I can log in to them and ping the other resource when the remote peering connection is established. Before we get started, I want to highlight something that I already previously mentioned, and I want to re-emphasize this. The dynamic routing gateway is different from the other gateways in the matter that is independent from the virtual cloud network. They do not exist within the virtual cloud network like the local peering gateway do or does, the NAT gateway does, the service gateway does, or the internet gateway does. The dynamic routing gateway needs to be attached, and you can actually delete the virtual cloud network, and the dynamic routing gateway can outlive. If you delete a virtual cloud network, other resources like the internet gateway and the local peering gateways will be deleted along with the VCN. So that's a key difference. And let's go ahead and get started. So there's two ways that you can attach a dynamic routing gateway into a VCN, but first we need to create them. So as I was mentioning, they're individual components. So as you can see here under networking, we don't have all the other gateways, but we do have the dynamic routing gateway. So let's go ahead and create one. And we are in Sydney. This is our region 1, so we are naming our DRG. It's going to be called DRG-1. And as easy as that. And it takes about a minute to create, a little bit less than that. So while it's being created, let's go ahead and create DRG2 in Melbourne. So it's being created. So I was mentioning that there's two ways that you can attach a dynamic routing gateway to a virtual cloud network, from the DRG itself or from the VCN itself. So while this is being created, let's go into Sydney. The creation should be complete by now. And yeah, it is available. So you go into the DRG, and here where it says virtual cloud network attachments, we don't have one. So let's go ahead and attach it to VCN1. The name is optional. If you do not customize the name, then OCI will decide for you, and it's going to be today's date down to the hour. So here you select your VCN1, and as easy as that, they're attached. So let's go to Melbourne and do the same thing, but rather than doing the DRG, this time we are going to do networking, click on virtual cloud networks, select our VCN2, and create the dynamic routing gateway attachment. Here, the name again is optional. And notice that we have the option, are we staying in our tenancy? If we were to connect to another tenancy, then we need to provide the DRG OSIT. In this case, we are going to be selecting the DRG and creating it. And there it is. We have our two attachments. Now let's go ahead and work on the peering. But while this is being created, we'll go into Sydney, click on the dynamic routing gateway. We have one. And you click on it. And you will see that you do not have any remote peering connection attachments. Again, The virtual cloud network is one attachment. The remote peering connection is another attachment. So you need to go ahead and create the remote peering connection attachment. And we are going to call this to Melbourne. And you create the attachment. And this is going to take a little while to create. Actually, it even takes a little while to display. So we'll do the same thing in Melbourne. We click on our DRG, find the remote peering connection attachments, create the remote peering connection, and we are going to call this to Sydney. So let's see how Sydney is doing. And you can see that while we're in the DRG, the attachment is attached. So you find your, this is the virtual cloud network. You need to go ahead and check the remote peering connection. And you can see that it's attached. And here's your remote peering connection. Now, as you can see, there is no peer status, not peered at all. In order to you to peer with the other DRG, you need to get this OSIT right here. You can show or you can copy. So I'm going to copy the OSIT from here and go to Melbourne. Find my DRG, my remote peering connection attachment. And here I establish the connection. And where do I want to connect to? So I want to connect to Sydney. And you find Sydney from this drop-down list. And here it is. And then you enter the OSIT that you just copied and establish the connection. And this will take a little while. While this is being created, remember there's an extra step that we need to take in each one of the regions, and that is to create a route in the route table that will take me to the DRG. So let's go ahead and do that here in Melbourne. I'm going to go into my networking, select my virtual cloud network, click on it, go to my route tables, and this time I'm selecting my default route table and adding a rule. So I'm in Melbourne, so I'm going to 10.0. .0.0/16. And here, because I only have one dynamic routing gateway, our attachment, it already pre-selected it for me, and I can enter a description, optional. And there we go, we have our route. Now we'll do the same thing in Sydney. Open my route table, click on the route table itself, outer rule, dynamic routing gateway. And here we're going to 192.168.0.0/16. So we should be complete by now. Let's go ahead and check the status of our connection, remote peering connection. You can see the status is peered. So we should have connectivity right now. Let's go ahead and check the addresses of those compute instances. And we'll choose one. We're in Sydney. So this is the address that we're pinging from Melbourne. So let me go ahead and, I'll just remember that it's the 164. Now I need the public IP address of Melbourne. And I'm going to open and here it is. So load, enter the address. Open it, and it opened my other window. So let me drag it into this window right here. And here it is. So I'm in BM2 in Melbourne, and I'm going to ping the address, if I'm not mistaken, was 10.0.0.164. And there it is. Remote printing connection is working. So that is the demo for today. I hope that it was of value to you, and I'm looking forward to seeing you in the next lesson. Thank you very much. Hello, welcome to Oracle University. Today we are doing a VPN Connect demo, and we are connecting from on-premises to OCI. This is the actual setting. These are the actual addresses that we're going to be configuring. Our VCN is 192.168.0.0/16. And the router that we have on premises, this is the actual IP address, the public IP address. This is the private CIDR. And we are going to be configuring the OCI side. What we have right here is Slivers 1. This is the customer premise equipment that we decided to use for this demo. And we are going to retrieve the information that we need to feed the customer premise equipment with. And every customer premise equipment, when you build the VPN connection, the tunnels, you need to create a device on OCI that represents this customer premise equipment. So let's go ahead and access our console so we can create everything from the ground up. We are creating everything from the ground up. We will be building a virtual cloud network. We will create a DRG and attach the VCN to the DRG. Update the routes. So we're creating a table, or actually we're creating a route in the route table that will take us to the DRG. So whenever we want to reach 172.31.0.0/16, we will be using the DRG, the Dynamic Routing Gateway. We need to create the customer premise equipment, as previously mentioned. And then we will create the IPsec tunnel. And with the information that we retrieve from the IPsec tunnel, like the addresses, the counterpart to the CPE, and the shared secrets, we'll collect those so we can configure the CPE. So let's go ahead and proceed. So in order for you to, because we're creating everything from the ground up, we'll create a virtual cloud network. And as you can see, I'm in my testing compartment. I don't have a single VCN in it in the Ashburn region. So we are going to be creating one using the wizard. And even though we have here a wizard for VPN connection, we are going to do everything from scratch. Feel free to, once that if you decide to do this as a lab, once you complete everything that you need, you can go ahead and then do the VPN connection. This is much easier. So I'm going to call this OCI VCN. The compartment is the correct one. Now the IP addresses, we decided to use 192.168. So that's what we are going to be configuring. Both our VCN and our subnet. And as you recall, this is all we need. This is going to be taking a little while. Normally the private subnet takes a little longer. In the meantime, we can advance and create the dynamic routing gateway. And this is easier. I'm gonna call this 2 on-prem, same compartment. And we should have our VCNs by now. So we can go ahead and create an attachment. I'll leave the name to OCI, so they'll fill this for us. This is the VCN that we just created. And while this is being attached, we can go ahead and update the route to the DRG. But in the meantime, we are going to create the CPE, the customer premise equipment. So this is the IP address. It is 54.67.20.17. And I'm going to call this, because this is Libras one. Libra is CPE. So again, this is 54. Now the vendor. As you can see, we have many vendors for you to select from. And here you can see that I have another tab called Verify CPE Devices. These are the devices. So we are using Livers one because that's the one that I downloaded into the compute instance that I have on premises and to the compute server. But if you go into OCI docs, into the documentation for VPN, you will see that we have a list of the verified CPE devices. And today we're only doing the OCI side, but if you decide to go further and learn how to configure the Livers one side, we have everything that you need, all the documentation, the configuration, and we even have a video that covers the OCI side. So feel free to go ahead and do that if you decide to do this demo as a lab. Okay, again, it's the verified CPE devices. We only have one version right now, so that's what we're selecting, and that's all we need. So again, the CPE is a representation of your router that you have on premises. And the use of it is that you can use the configuration helper. And once you configure your tunnels, this will have all the information that you need that you can take to the router, because you need to inform the router of the OCI side. And currently we don't have any IPsec connection, but that's the next step. We still have pending the route to the to on premises on the VCN. So let's go ahead and add that route. So as you can see, by default, the wizard created a route to the internet gateway. So we are going to add a route rule. And right now we're going to the dynamic routing gateway. And our destination can be, it was 172.31.0.0.16. You just want to make sure that's what it is. So the route is there. We have the CPE device. Now let's go ahead and create the IPsec tunnel. We need to select the customer premise equipment that we created, the dynamic routing gateway. Now the static route, in this case, we're using static routes. You can also select to do a BGP for another occasion. So 172.16.0.0/. It was not 16, it was 31. So the previous time that we entered this was in the route table. That was for routing purposes. This is for the VPN itself. So now we're creating the IPsec connection. And it's going to take a couple of minutes. And once these are in the provision state, these will remain down. They're available. They're down because we need to configure the on-prem side, and this is what we were waiting for. So we need to take these IP addresses and let the CP know that they need to connect to OCI to these IP addresses, but they also need our shared secret. And for you to retrieve the shared secret, you go on each one of the tunnels. This is the long way, by the way. And here's the shared secret. You can show it, or you can go ahead and edit it in case you want to change it. Now, I mentioned that this is the long way. What is the short way? So let's go ahead and find our customer premise equipment. And I was mentioning, so it moved to here. I was mentioning that we can use the configuration helper and we can create the content based on all the information that we have so far. And this is what you will take to your router side. And you can see here we have the public IP address. This is the static IP. And we should have the shared secrets, and they're right here. This is one of them. Okay. And take this information to the customer premise equipment. And once I do that, then these tunnels should come to the state of up. So see you in a couple of minutes. Bye. Hello, and we are back. And as you can see, the IPsec status now has a state of being up, both tunnels. So this completes this demo. Thank you very much. Bye. Welcome to a new lesson of Oracle Cloud Infrastructure Connectivity. This is a demo of Fast Connect. We're actually seeing a demo, and this demo is a little bit different from the previous demos that we have done, as the Fast Connect circuit is already in place. It's already configured, up and running, and I'm going to demonstrate to you how to create one similar to the one that I'm showcasing. So you can imagine creating a digital circuit from on-premise to Oracle Cloud Infrastructure. It's a little bit more elaborated than creating a VPN connection, where you already have the internet connectivity, and it's a free service. Fast Connect, you have to pay for the port on the OCI side, and then if you have a vendor, you have to pay that vendor as well. A partner, you need a partner to establish the Fast Connect connection. And then if you have the other end of that partner, it might be another cloud provider, it might be that partner is providing you services in their own data center, or you might have an SD-WAN provider that you're connecting to. So there's many variables involved, and that's why we are demonstrating something that is already in place, but we'll demo how we got there. So let's go ahead and take a look. As you can see, I am in the Ashburn region, and if I go into networking and under customer connectivity, I can find my Fast Connect circuit, and it's located in the compartment properly named as Fast Connect. And I name my link to on-premise because I'm going to, and on-premise, you can see that it's provision. The IPv4 border gateway protocol state is up. So it's IPv6, the state is up. And this is not common. Normally, not a lot of people have IPv6. This was for a troubleshooting purpose. And the access to on-site will use IPv6 to ping the other end, because that's what we have so far. So if we click on the name of our Fast Connect circuit, you will see the details of it. Here you will see that the state is up and that is a 10 gigabits per second circuit using the partner Equinix. The virtual circuit is activated. The virtual circuit is private. The other option, it could be public. This is a private circuit. When it was created, and the dynamic routing gateway that is attached to. Remember that the Fast Connect is also an attachment. Virtual circuit is an attachment to the dynamic routing gateway. So let's go ahead and take a look of our dynamic routing gateway. The name of it is Hub DRG to on-prem. Here you can see that I have one VCN attached to this dynamic routing gateway. Here's my virtual circuit attachment. I have two IPsec tunnels, and I have two remote peering connections. So as you can see, this is a very active dynamic routing gateway. And if you click on the attachment name, then you can see more details. As you can see, it has a route table that I'm calling two local peering gateways. So this is, just by looking at this, you can tell that this is a hub and spoke. Now let's go back into customer connectivity, because I want to show you how it is that we created this Fast Connect. So Fast Connect is right here, and we are going to be clicking here, create a Fast Connect. This is a fictitious one. You have two options. Fictitious because it's not going to complete the circuit all the way to the other end. It's just how is it that you configure one in Oracle Cloud Infrastructure. So you have two options, selecting the Fast Connect Partner or Fast Connect Direct. Now, Fast Connect Partner means that there's a third party involved that already has an agreement with Oracle Cloud Infrastructure, and you can start the connectivity here at Oracle Cloud Infrastructure. You are going to get an OSIP that you need to take into that partner, and that partner is going to be using it to connect and establish the link, or the link between the Oracle Cloud Infrastructure and them. Then they're the guy in the middle. Normally, you're trying to establish connectivity to on-premises, so they have a way for you as a customer to connect, and you will need to speak with them. So who are these partners? So here we have AT&T Netbond, British Telecom, and a boatload of other partners that you can select from here. And please notice that these are the partners available in the US Ashburn region. If you select another region, let's go into Frankfurt, for example, then you will see that the partner list is different there. It looks pretty much similar, a whole boatload. Let's go into Santiago de Chile. So South America, so it should be, here it is. So as you can see, not all regions have the same amount of partners. Not all regions have the same partners, so it's a little bit more limited over there. And but these are the partners that you have in Santiago de Chile. So let's go ahead and check back to Ashburn. This is where we are. And now I want to point to Fast Connect Direct. So on Fast Connect Direct, you don't have a partner because it's a direct. You need another vendor that is going to help you complete the connection into OCI. OCI is not a carrier, and we only offer the port. That's what we offer. And somebody needs to help you plug in the physical connectivity into our resources. And in this case, basically, you need to go into the data center, and this is what POP means, point of presence, and we will issue a letter of authority once you complete this process. So you give it a name, you select the compartment, and then you have two options, single cross connect. So this in case link aggregation protocol is not supported, or cross connect if you want to support link aggregation. Link aggregation basically allows you to have two physical connections act as one. So let's go ahead with this one. And then you give it a name, select the speed, 100 gigs is supported in Ashburn. Then you fill in the rest of the links, hit create. And the minute that you hit create, I will issue a letter of authority that you can download and go into the data center with a partner and finish the connection. If the partner's already in that data center, then it's going to be a patch cable, basically. If the partner's not there, then they'll need to make sure that physical connectivity gets from on-premise into that partner. If I hit create, it's going to fail because I don't have enough service limits. Let me show you. If you don't have service limits, then you'll get a message. So here I'm going to select Equinix again, click create, and I don't have service limits, then I get this message. I was expecting this, but let's go ahead and go to the previous window. Now select Fast Connect Partner, and here we previously, for the connection that we have up, we're using Equinix. Now I can go ahead and click Next. And then I need to provide all of these information. It's going to be a private virtual circuit. The private virtual circuit is the one that we have up and running right now. And basically, it is used to connect your private resources on a virtual cloud network into on-premises. The public virtual circuit will help you connect the Oracle services network services with your private network that you have on premises. Then here you specify what dynamic routing gateway you're going to be using and what bandwidth. And here you see that we have these options all the way to 10 gigabits per second. Now here's where you enter the IPv4 address of the routers. And if you want to establish IPv6, you can go ahead and do this. And this is basically what we're creating here is a router in the middle. And you can use these ones. You're perfectly fine. /30 means that you only have 4 possible addresses. And if you enable IPv6, then you have to enter those addresses as well. And then customer border gateway protocol autonomous system number, you need to enter it here. Normally it's a 5-digit. So let me type something, 5, 6, 7, 8, 9. Not sure if that's going to work. And then if you have this information, you go ahead and fill it. And then you click create. And this will start the creating process. And here it will let you know what's next. So you take the OSIT and you take it to the partner, in this case, Equinix. And once this completes, it's going to go into the down state. And once it's in the down state, it's because you also need to go into the customer, into the partner and provision on the partner's portal. And once you complete that, then if there's a third-party portal, then you need to fill that as well. The third-party portal means the third link of the connection. And that's basically it. So once you have your Fast Connect up and running, like this one is up and running right now, you can connect to your VM and test the connectivity. And here it is. I mentioned that I was going to ping an IPv6 address because that's what we have at the other end. And you go ahead and ping, and you can tell that these resources are very close to each other at the other end because it's 1.26, 1.27. So the millisecond or the latency is very small. And if you recall from the remote peering connection between Melbourne and Sydney, it was greater than that because the distance is much greater. These resources are in the same data center, basically, or the same campus. So that's why the latency is so small. So this completes the lab. I hope that it has been of value to you, and I'm looking forward to seeing you in the next lesson. Thank you very much.